So you get the idea, right? So when you cut and paste magnetic field lines this way, you can transfer some particles from the magnetic field of the solar wind to the magnetic field of the Earth. Can you do that? Do you have good eyes? Do you have a different color? Is it just white? Yeah. Okay, I'm going to destroy this piece of beauty here. It's something.
Yeah, go ahead. You can take those down.
All right, so here is the Earth. Here is a magnetic field line of the Earth. And here are some particles, electrons, protons, whatever, trapped along this field line, right? Here comes the solar wind, and it's of opposite direction. We have particles, solar wind particles here. Do I? Yes, I do. Now, here comes the blue color. So when they reconnect, you form two new field lines. You reconnect right here, and you form one field line that looks like this, and another field line that looks like this. Now, let's see what particles this field line connects. From here to here, it has the orange particles, right? From here to here, it has the orange particles. Then on this part, it has the white particles, right? Now let's see. This is the new field line. It has now particles from the solar wind and from the Earth. You see what happens? Now the difference is that the particles from the solar wind are much more energetic. What are they going to do? They're going to come down to the poles. And then what? Produce northern lights, southern lights. Is that what I'm going to get you ready for college? Another half an hour. Yes.
When so the solar wind is going one way and the magnetic field is going the other way. Since it's going the opposite ways, does that mean they're
so the solar wind is coming this way.
Yeah.
And the solar wind is dragging, is pushing the interplanetary magnetic field towards the Earth.
Yeah.
See, it's just piling. When it gets here, we have a constant supply of solar wind particles. You see, you can imagine this is a dynamic process. So after this field line reconnects, there will be more to come. Okay?
So does that mean they're like opposite charge though?
No, so here you have what?
Oh.
This could be a proton, could be an electron. Here you can have some, again, protons, some electrons. But with these orange particles, they are more energetic than the particles that are already here. Okay, that's the distinction. And once these solar wind particles get along the Earth's magnetic field line, then they will go towards the poles. That's how you get the northern and southern lights. Now, well, the opposite could happen too. The interplanetary magnetic field could be of the same direction as the direction of the Earth's magnetic field. What's going to happen then? You think anything is going to happen? You think we're going to have this process? No.
They would power, right?
No. Basically, the Earth's magnetic field is going to slide around and it's going to continue in space. It's just going to slip around and continue. But there will be no reconnection. There will be no exchange of particles between the solar wind and the Earth's magnetic field. Okay? So, when are conditions, the conditions in outer space like this? About 2% of the time. So on average, the Earth's magnetic field deflects about 97% of the solar wind particles. And only 3% can penetrate. And these 3% of solid particles that enter the Earth's magnetic field, they are the ones that produce northern lights and southern lights.
The pretty one.